Okay, so those are different parts of radicals, and that's what we are talking about today. Okay, now let's look at the two examples that I have down here. In these two examples, you can see that we have two numbers. We have a 72 here, and down here we have a 600. We're going to talk about this one first. I'm going to show you two different ways that you can work with these problems, so you kind of would then get to choose which works best for you. Personally, I kind of use a mixture of the two depending on what number is given to me. Okay, so as we go to do this problem, okay, let's look at the number that is there, 72. 72 is not a perfect square, okay? So this is dealing with taking the square root of a non-perfect square. So 72 is not a perfect square, okay? So we have to keep that in mind for this problem here. So one thing that you can start to think about are the factors of 72, right? So if you break 72 down, can you think of any perfect squares that go into 72? Well, a perfect square that goes into 72 is 9. So I'm going to write my radical symbol, and then I'm going to write a 9, and think about, well, what would I multiply to 9 to get 72? Well, that would be 8, right? Now, 9 is a perfect square, but 8 is not. Can you think of a number, break down 8 a little bit more, you think of a number that goes into 8 that's a perfect square? And if you don't remember, go back to our list up here at the top in the warm-up and look at those first 12 perfect squares. Those are the ones that are going to be the most common, and it's a good idea to know them. So the next perfect square I know that goes into 8 is going to be 4, and 8 is 4 times 2. So there's the breakdown. And then when you go to do this next step, again, I'm going to use a think bubble here because I'm not going to write this step necessarily, but I'm going to think about it. I'm going to think about, what's the square root of 9? What's the square root of 4? What's the square root of 2? Now remember, 2 is not a perfect square. 2 is what we call a prime number. It doesn't factor down any further, so keep that in mind. So as we go to do this, I know that the square root of 9 is 3. I know that the square root of 4 is 2, and I know that the square root of 2, well, 2 is a prime number, so I just leave it as square root of 2, okay? And then the last step that you're going to take here is you're going to simplify these numbers that are here on the outside of the radical. Those are going to become your coefficient. 3 times 2 is going to be 6. I'm just going to move this down a little bit. Okay, 3 times 2 is 6, and then the square root of 2, we can't do anything with that, so we just leave it as square root of 2. Okay, so if you wanted to check your answer, you could quickly check your answer by taking this number on the outside and squaring it, that would be 36, and multiplying it to the number that was left inside, and it should give you what you started with. So I know it's right. You don't have to check it, but it's always a good idea to know how to check it if you wanted to. Okay, let's look at our other option over here. Now, one thing that we have talked about is prime factorization. So that's what I'm going to use on this one. I'm going to look for pairs of numbers because I know that when you multiply pairs of numbers, I get a perfect square number. So in this method, I'm going to use some prime factorization. Okay, so I'm going to take the number of 72 and I'm going to break it down into all prime numbers. 72 is 9 times 8. 9 is 3 times 3. This method works really well if you don't necessarily know your perfect square numbers. And the other thing you'll notice as I'm doing my prime factorization is I like to circle my prime numbers so that when I go to write my prime factorization, I can very easily see what all my prime numbers are because I've circled them. And I didn't circle the ones that are not part of my prime factorization. So going back to my problem here, I'm going to rewrite 72 underneath the radical using my prime factorization. The other thing that I suggest to do is to write your numbers in order, grouped together with their like numbers. So I like to write all my 2's first, all my 3's next, all my 5's after that, and so on and so forth. It makes this method a lot easier to use. So as I go to do the next step, what I'm going to be looking for here is I'm going to be looking for pairs of numbers. Okay, so we're going to look for pairs of numbers because I know that a pair like 2 times 2 makes 4, and 4 is a perfect square, right? So what is the square root of 4? Yeah, it's 2. So from the square root of 2 times 2, which is actually the square root of 4, out a 2 is going to come. And this is no longer going to be underneath your radical. And then the next thing is look at any more pairs that you have. Well, I have a pair of 3's. A pair of 2 numbers multiplied together will make a perfect square. This makes this, a 9, and we know that the square root of 9 is 3. Right? So this guy's in my way. I'm going to move him up a little bit. So on this here, right? Sorry, I'm just trying to move all this stuff because it kind of got messed up a little bit. Okay, so what you can see now is that I have a 2 and a 3 on the outside, and I have a 2 here that wasn't used at all. So remember, we can't take the square root of 2. It's a prime number. So this stuff that's on the outside, if you look over on this method, it's the same numbers that we had on the outside here. So then any of the numbers that are on the outside, what you're going to do with them is you're going to multiply them together, and then you're going to take that multiplication and you're going to bring it to the front of your radical. So what this becomes, because 2 times 3 is 6, it becomes 6. Then you have your radical symbol, and then you write any of the numbers that were left behind, and that's a 2. This is also another reason why, like, as I'm doing these problems, different things that you can do to designate that they have been taken out of the radical is circle them, cross them out, or maybe highlight them. And then by doing that, it makes it really easy to see what is left behind. If you happen to have more than one number left behind underneath the radical, as long as they don't make a perfect square, you just multiply them together and put that product underneath the radical. And you can see that you get the same exact answer. Now you might ask, why do this method when you have this method? Well, maybe you don't know any perfect squares that go into a number, or the number is really large, so sometimes you might sometimes you might have to take a little bit of a different route. Okay, so I hope that helps with those 2 problems. This problem here is going to be an example for you to try. So on these, you're going to try it. You're going to pick one way. Pick a method. Or maybe you want to use a combo of both methods, right? But you only have to do it once. So do the problem once. So do it once. So pause this video, take a moment, and see if you can try this one. Okay, so you should have tried that one. Let's talk about what you get for these problems. Okay, so hopefully you took a moment and tried these out. I'm going to go through the work for these. When I think about the number 600, now as I do this, you're going to see that I'm just going to bring the coefficient on the outside and leave it there. I'll deal with that later. When I think about 600, anything that ends in 2 zeros has the number 100 as a factor. So 100 times 6. Right? Now I know 100 is a perfect square, but 6 is not. There are no perfect squares that go into 6, because the only factors of 6 are 3 and 2. So you could essentially skip this step if you're already thinking about it, or maybe you just factor it out just to make sure. So what you're going to do here is you're going to take the square root of 100. I know that the square root of 100 is 10, so I'm just going to make a little note right there. So that's no longer underneath the radical. So that's why I circle it. It's gone. If you want to cross it out, you can. It doesn't really matter. Okay. So, so then what you're going to do here is you are going to take that 10 and you're going to multiply it to the coefficient in front. The coefficient in front is 2. 10 times 2 is 20. And then remember, if I said underneath, if you have more than one number left, just multiply them back together and put it there. So you would get 20 square root of 6. Now, if you chose to use the prime factorization method, well, the first thing you would have to do is prime factor 600, which might take you a bit of time, huh? So I know 100 goes into it, and 6 breaks down to 3 times 2, those are prime. 10 breaks down to 100, breaks down to, there's different ways you could break it down. Maybe you thought about 50 times 2. And 25 is 25 times 2. And maybe you stop there even, right? And you have a 2 times a 2 times a 2 times a 3, and then you have a 25. You're like, well, 25 is a perfect square, so I could essentially stop there and kind of do a combo of each of the two methods, right? Or maybe you don't notice it, and you want to continue factoring the whole way down to prime numbers, right? So there's our option. So then as I go to write, I'll use a different color here so we don't get confused. There's a lot going on here. I can even erase this. Oh, my line went away. Okay, so what I get here is I get a 2 on the outside, and then underneath I have all kinds of numbers. I have 3 2s, I have a 3, and I have 2 5s, right? So now what you're doing is you're looking for perfect squares, which would be pairs of numbers. So I'll use a highlighter this time, change it up. Here's a pair, and here's a pair, right? For each pair, basically what ends up happening is a number comes out, because 2 times 2 is 4, and the square root of 4 is 2. 5 times 5 is 25, and the square root of 25 is 5. You're going to multiply those numbers that have come out, and you're going to make sure to multiply them to this number as well. So what you have here is you have a 5 times a 2 times this 2 as well, which gives you 20. And the only thing left underneath is the 2 times 3, so you get a 6. And you get the same exact answer. Ta-da! So take this knowledge and use it on your assignment or in your class today. And I hope you enjoyed this video, and good luck with your work.